Hello everyone and welcome to my presentation. First, I will introduce myself. My name is Saadi Moufida. I am PhD student in electrical engineer at University of Tbilisi. Today, I will gonna be talking about for important topic. It is vector control of double feed induction generator for wind energy conversion system. So let's get started with presentation plan. Firstly, introduction. Then wind turbine conversion system, and then turbine control strategy, and the last simulation results and future scope. So, consider today the amount of energy extracted from renewable resources and especially from wind as a competitive and necessary alternative to fossil resources. The use of wind energy has grown during the last few years, which led to an increase of research and development of larger and effective wind turbines in order to offer renewable energy to the cosmos. The aim of this work, we present a PPT control of wind energy conversion system based on double feed induction generator controlled by vector control and show its effectiveness when added in the system. Wind energy conversion system converts wind energy into electrical energy, which is then fed into electrical grid. The turbine rotor, gearbox, and generator are the main three components for energy conversion. Rotor converts wind energy to mechanical energy. Gearbox is used to adapt to the rotor speed to the generator speed. Generator with variable speed when turbine alone with electronic inverter absorb mechanical power and convert to energy electrical energy. Okay, the wind turbine is playing a cardinal role in the entire system as it is responsible for the generator of mechanical power needed to drive the generator. The primary factor on which the wind turbine performance depend are wind speed, direction of wind, blade size, and pitch angle. Okay, on training and leveling wind speeds with this their equation, the aerodynamic power, wind power, the mechanical torque, and the power coefficient. Okay, turbine model. The block diagram figure 3 corresponding to this modeling of the turbine, the input of the turbine are the wind speed, the angle of orientation of the blades beta, and the speed of rotation of the turbine. The diagram shows that the speed of the turbine can be controlled by acting on two inputs, the angle of the blade beta and the magnetic torque of the generator when speed is considered a, dis, a disturbing input to this system. Okay, modeling the double feed induction generator, two power converter bridges connected back to back by main of the DC link can accommodate the bidirectional rotor power flow in a double feed induction generator. The purpose of this of the grid side converter in to maintain the DC link voltage constant It has control over the active and reactive power transfer between the rotor and the grid. The rotor side converter is responsible for control of the flow and the stator active and reactive power. Okay. Wind turbine control strategy. The control strategy consists of speed control using a maximum power point tracking (MPPT control), a series band pulse with modulate current control (PWM), filed oriented control of a double fed. Okay, the first one, MPPT without speed control. In this case, the power generated and electromechanic torque developed settle time equal to the reference value. In this case, the amount of considering the mechanical torque developed as zero. So, neglecting the viscous friction torque is zero. Okay, and direction filed oriented control. The aim of this control is to RCF model equivalent to the DC machine and perform a real time torque control. Both reference current are compared separately with the real-time motor current where they controlled by proportional integral regulator. Okay, simulation results. We will present the results of simulation of the operation of the electric part of generator, which are made in MATLAB Simulink environment. This result obtained based on the control structure without speed control. The setting angle will be constant alone. The simulation at the values 9.1 in a zero point 0.5 seconds. The figure present show wind of variable speed. Okay. The figure present show the figure presented show the performance of double-feed induction generator rotor, which is driven by wind turbine. There is good monitoring of the step one for the active power as well as the reactive power, stator power. Okay, which is preserved zero by the real power supplied by the double feed induction. The same here for the stator current um, response. Okay, conclusion. This work provides a modeling, simulation, and control of a deficit induction generator based wind conversion system. The indirect vector control method is used to control the stator flow or the deficit induction generator, allowing independent control and hence the active and reactive state of power of the double feed induction generator drive by a variable speed wind turbine. The reference of the active power generated by the double feed induction generator is set according to the wind speed using a maximum power point tracking strategy. The simulation results show the effectiveness of the decoupling controller and the MPPT strategy and can be used to investigate other more robust control strategy of improve the performance of the system in response of power disturbances. It can be said that the proposed vector control strategy of double feed induction generator in a very simple, robust control algorithm uh, which has the advantage of being easily for a real-time implementation. Okay, future scope, the conversion system can be optimized by performing an advanced MPPT algorithm using pitch angle and yaw technique. Moreover, a detailed study to convert system connected to the grid and battery for the stand-alone turbine mode. Thank you.